Tsunamis are some of the most powerful and destructive forces of nature, capable of reshaping coastlines and causing widespread devastation. But how do they form? What causes these massive waves to suddenly appear? Understanding the science behind tsunamis is key to not only grasping their power, but also to being able to prepare for and minimize their impact. Tsunamis aren't like the regular waves you might see at the beach. These waves are much larger and far more dangerous, and their formation starts deep beneath the ocean's surface. Unlike normal waves, which are driven by wind, tsunamis are usually caused by sudden, massive changes in the ocean floor. This can happen for a variety of reasons, but the most common cause is underwater earthquakes. When an earthquake occurs beneath the ocean, the Earth's crust shifts dramatically. This shift can displace an enormous amount of water, creating a series of waves that spread out from the point of the earthquake. These waves can travel at speeds of up to 500 miles per hour across the open ocean, making them extremely fast and difficult to detect. In fact, even though a tsunami can be triggered miles from shore, it often goes unnoticed until the waves start to approach land. What's unique about these waves is that even though they travel incredibly fast, their height is relatively small in deep water, often only a few feet tall. This is why, in the open ocean, ships and boats won't notice a tsunami, as the waves pass beneath them without causing much disruption. But as the waves get closer to shore, the water begins to slow down and the waves begin to grow in height. This is where the real danger lies. When the tsunami reaches the coastline, the water can surge hundreds of feet into the air, creating massive walls of water that crash onto the land. The biggest challenge with tsunamis is their unpredictability. While we have some understanding of the factors that cause them, we still don't know exactly when or where they will occur. And even though we know what triggers tsunamis, there's no real way to predict exactly how big they will be or how far they will travel. This makes it extremely difficult to prepare for their impact, as there's often little to no warning before they strike. The effects of a tsunami can be catastrophic. When a tsunami hits land, it doesn't just cause damage from the waves themselves, but it can also trigger flooding, erosion, and destruction of infrastructure. Coastal communities are particularly vulnerable, as the waves can travel miles inland, sweeping away homes, buildings, and anything else in their path. Even more concerning is the potential for massive loss of life, especially in densely populated areas. And one of the most devastating examples of a tsunami occurred in December of 2004 when a powerful earthquake off the coast of Indonesia triggered a massive tsunami. This tsunami affected countries across the Indian Ocean, including Thailand, Sri Lanka, and India. The waves reached as far as Africa, and more than 200,000 people lost their lives as a result. The 2004 Indian Ocean tsunami serves as a tragic reminder of just how dangerous and unpredictable these natural disasters can be. The impact of tsunamis can extend far beyond the immediate coastline, affecting global trade, tourism, and commerce. In the wake of a tsunami, it can take months or even years for affected areas to recover. So understanding how tsunamis form and recognizing the warning signs is crucial for minimizing their impact and saving lives. Now that we've covered the basics of tsunami formation, we'll dive deeper into the factors that contribute to these massive waves, including underwater earthquakes, volcanic eruptions, and landslides. In the previous part, we explored the basics of tsunamis, but now let's dive deeper into one of the main causes of these devastating waves, underwater earthquakes. These natural events play a major role in generating tsunamis, and understanding how they work can shed light on the formation of these powerful waves. Underwater earthquakes occur when the Earth's tectonic plates shift, usually along fault lines beneath the ocean. The Earth's crust is made up of large, rigid plates that float on the semi-fluid mantle underneath. These plates are constantly moving, and when they collide, slide past one another, or separate, it causes stress to build up along fault lines. Eventually, the pressure becomes too great and the plates suddenly shift, releasing massive amounts of energy in the form of an earthquake. When an earthquake occurs beneath the ocean, the ground can move up or down, displacing the water above it. This sudden displacement is what generates the waves that we know as tsunamis. The size of the tsunami depends on several factors, including the magnitude of the earthquake, the depth of the earthquake's epicenter, and the type of fault movement. For example, a vertical shift in the ocean floor is more likely to displace large amounts of water, creating a higher tsunami wave compared to horizontal movements. The bigger the shift, the more water gets displaced, and the larger the tsunami can become. This is why more powerful earthquakes, such as those with a magnitude of 7 or higher, are more likely to trigger large tsunamis. One important thing to understand is that while the earthquake itself may only last for a few seconds or minutes, the resulting tsunami waves can continue to travel for hours. These waves can affect vast areas, crossing entire oceans and hitting multiple coastlines before they dissipate. The energy from the earthquake spreads across the ocean, causing a chain reaction of waves that grow in height as they approach the shore. Another critical factor in tsunami formation is the location of the earthquake. Tsunamis are most commonly triggered by earthquakes that occur along subduction zones, where one tectonic plate is forced beneath another. These areas are often located along the Pacific Ring of Fire, a region known for frequent earthquakes and volcanic activity. Countries like Japan, Chile, and Indonesia are especially vulnerable to tsunamis due to their proximity to these subduction zones. A classic example of a tsunami triggered by an underwater earthquake is the devastating event that occurred on December 26, 2004. A massive earthquake with a magnitude of 9.1 struck off the coast of Sumatra, Indonesia, causing the ocean floor to shift dramatically. This earthquake generated a tsunami that affected countries across the Indian Ocean, including Thailand, Sri Lanka, and even parts of Africa. The waves reached heights of over 30 meters in some areas, causing widespread devastation and loss of life. While underwater earthquakes are a significant cause of tsunamis, they are not the only factor at play. Other events, like volcanic eruptions and underwater landslides, can also trigger tsunami waves. In the next part, we will explore how these factors contribute to tsunami formation and the effects they can have on coastal areas. Stay tuned. In the previous part, we looked at how underwater earthquakes trigger tsunamis, but now let's explore two other powerful forces that can cause tsunamis: volcanic eruptions and underwater landslides. Both of these events can displace massive amounts of water, leading to waves that can travel across the ocean and cause significant damage to coastal areas. Volcanic eruptions can be another key trigger of tsunamis, especially when they occur beneath the ocean. While we usually associate volcanic eruptions with lava flows and explosive ash clouds, when they happen underwater, they can create massive disturbances in the water above. One way that volcanic eruptions trigger tsunamis is through the collapse of a volcanic island or underwater caldera. A caldera is a large bowl-shaped crater that forms when a volcano collapses after an eruption. When the volcano's magma chamber empties, the pressure from the underlying layers of earth can cause the seafloor to drop rapidly, displacing huge amounts of water. This sudden drop in the seafloor can send waves racing across the ocean, much like the waves created by an earthquake. Another way that volcanic eruptions can cause tsunamis is through pyroclastic flows. These fast-moving, hot mixtures of ash, gas, and volcanic debris can travel at high speeds across the ocean surface. When they enter the water, they displace large amounts of water, generating waves. These waves may not be as large as those created by an earthquake or a caldera collapse, but they can still cause significant damage along coastlines. A notable example of a volcanic eruption triggering a tsunami occurred in August of 1923 in Japan. A violent eruption of the Sakurajima volcano created pyroclastic flows that traveled into the sea, displacing enough water to create tsunami waves that caused significant damage to nearby coastal communities. Underwater landslides, also known as submarine landslides, can also be responsible for generating tsunamis. These landslides happen when large amounts of sediment, rocks, or debris move suddenly down the continental slope or underwater slopes. The displaced material causes the water above it to move rapidly, creating waves that can travel across the ocean. Submarine landslides can occur for several reasons, including earthquakes, volcanic activity, or even the buildup of excess water in an area. These landslides are often triggered by the destabilization of the seafloor, which can occur when an underwater earthquake shakes loose sediment and rock. In other cases, volcanic eruptions or underwater mining operations can also displace material, triggering landslides. One infamous case of a tsunami caused by an underwater landslide took place in 1998 off the coast of Papua New Guinea. A massive landslide, triggered by an undersea earthquake, sent waves of up to 10 meters high crashing into the nearby coastline, resulting in over 2,000 deaths and widespread damage. Submarine landslides are often harder to predict than earthquakes or volcanic eruptions. making them a significant threat in areas where underwater slopes are unstable. They can occur suddenly and without warning, adding to the complexity of tsunami forecasting and preparation. In the next part, we will explore the effects of tsunamis and how they impact coastal communities from the first signs of a tsunami to the aftermath of a devastating wave. Stay tuned for more on this powerful natural phenomenon. Now that we've explored the science behind how tsunamis form, it's time to take a closer look at their impact and the importance of preparation. Tsunamis can be one of the most devastating natural disasters, capable of causing massive destruction in a very short amount of time. While the waves themselves can arrive quickly, the damage they leave behind can last for years, affecting entire communities and economies. When a tsunami hits, the first wave is often not the largest, and multiple waves can follow. These waves can travel across vast distances, and the time between waves can range from minutes to hours. The waves can be extremely powerful, reaching heights of up to 100 feet or more. Depending on the size of the event, the force of the water can cause buildings to collapse, sweep away vehicles, and flood entire cities. Coastal areas are especially vulnerable as they are directly in the path of the waves. The damage caused by a tsunami isn't just physical. The waves can also severely impact the environment, destroying marine ecosystems, beaches, and vital coastal habitats. The displacement of water can lead to changes in local water quality, and the debris carried by the waves can spread pollutants. In the aftermath of a tsunami, the economic costs can be enormous, especially for communities that rely on tourism, fishing, or trade for their livelihood. In addition to the immediate destruction, tsunamis can leave long-term effects that persist for years. Communities often face rebuilding efforts that can take decades, and many people are displaced from their homes either temporarily or permanently. It can take a long time for people to return to their normal lives, and recovery efforts can be hindered by damaged infrastructure, lack of resources, and challenges in coordinating aid. Despite the devastation caused by tsunamis, there are ways to mitigate their impact. One of the most important factors in minimizing the destruction of a tsunami is early warning systems. Tsunami warning systems rely on networks of sensors placed on the ocean floor to detect changes in water pressure caused by earthquakes or underwater landslides. When a potential tsunami is detected, warnings are issued to coastal communities, giving them time to evacuate to higher ground. Tsunami evacuation plans and drills are essential for preparing people for these events. Communities in high-risk areas must have clear evacuation routes and safe zones, and local authorities must ensure that residents are educated on what to do if a tsunami occurs. The quicker people can evacuate, the more lives can be saved. Another important factor in minimizing the impact of tsunamis is effective building codes and infrastructure design. In areas where tsunamis are a known risk, buildings should be constructed with materials and designs that can withstand the force of the waves. Coastal barriers, like seawalls or floodgates, can also help protect vulnerable areas from flooding. Tsunamis are unpredictable and can strike at any time, but through increased awareness, preparation, and the use of technology, we can reduce their devastating effects. By studying past events and improving our understanding of tsunami formation, we can develop better strategies for both prevention and recovery. Understanding how tsunamis form and their potential impact is essential for preparing communities and saving lives. If you're interested in learning more about natural disasters and how they shape our world, be sure to check out my next video. Stay safe, and remember that preparedness is key when it comes to surviving a tsunami.